We're now going to continue this tutorial, and we're going to learn how to uh, create Netcdf files. So I'm going to open again the Netcdf tutorial, and I'm going to go to tutorial number 2. So this is going to be tutorial 2. Okay. So in this second tutorial, I'm going to begin by creating a Matlab script that generates an Netcdf file. And I'm going to create this script using in the existing Netcdf file of the SST. So for example, if we go in this directory, I'm going to say that file equals the no SST thing, because it's easy to start with something that we have and then modify it. So here I've used this as being the original file, and I'm now going to create a script, a Matlab script, that actually recreates the structure of this Netcdf file, an empty structure of this Netcdf file. I know in principle you could just copy it, copy this Netcdf file, but the idea of generating a script is that then we can modify to create different types of Netcdf files. So the command that I'm going to use to generate a template Matlab script is going to be this one, nccdl. So you give the NIF the file, which is the existing Netcdf file structure, and you're going to create, a temporary dummy file that, say, call it mysst.nc. So let's execute this script here, and let's press return. So now, at the end of the script, it tells you that it created an M file that is called mysst.cdl. Let's open this this particular M file, which is a Matlab script. And here, what you have now is a Matlab script that will generate a Netcdf file that has the exact same structure of the one that we began with. So for example, here you can say nc Netcdf file equals this and so forth. So let's assume that we want to create now a Netcdf file for sea level pressure, for example. So I can go here and say inst slp. I can modify this, then I can go down here, and let's assume that the sea level pressure has different longitudes and latitudes. Or let's say that it even has an additional dimension, which we can add here. Suppose that there is depth. We're just gonna, let's say that it has 2 depth values per se. This is just an example, for depth value. So if that's the case, maybe we shouldn't call it sea level pressure. We can just call it the pressure field in general. So let's call this pressure. Okay. And then we can go down. We have longitude, latitudes, and so forth. Then we may want to have an array that defines the depth. Okay. So we could just copy something like this, for example. And we don't have to add all the fields, but we could just put, for example, just a couple of them. Let's say this. We call this depth. Depth and depth. And so this is going to be down. The units are going to be, for example, say meters. It's meters. The long name for this is just going to be depth. Depth. And the dimension of this is actually going to be also depth. So now I have a new structure here, a new variable. But sorry, I have both a dimension that is called depth and a variable that I call depth. Okay. So then I have time. I can leave here the same value, but instead of having so many time arrays, I'm just going to say that if I go here in the time array, I'm just going to have like, only one record, for example. Okay. And I can do that. And then I'm going to go down. And now instead of having SST here, I'm going to redefine this to be pressure. So I can do Cebu pressure, and I can just change all these, and I can go on and on and on. But now, just for simplicity, I'm just gonna have just the end short and long name, but you could, in principle, you could have as many fields as you want. So I'm just gonna have these two, because okay, and this is gonna be pressure. Pressure field. Okay. Okay, so now I save this and I can move this particular script into something like create underscore pressure nc.m. Okay, so this is it's a script that creates the pressure. So I can just execute now this script. And it's giving me an error. There's an incomplete string somewhere. So let's open this and let's see where I made, where I made this mistake. And this is good that I made this mistake, because it just shows that things are not straightforward as usual. And it may be over here somewhere. Let's see, we added this depth array. I don't know. Let me just re-execute it. Maybe it's going to tell me a little bit better. Incomplete string on line 22. Sorry, line 12. So let's go on line 12. Okay, so sometimes these NC comments may... see, this string was very long, and it went for more than one thing here. So I'm just going to remove this comment here. Here we go. Okay. In fact, I don't want to have, you can change these global attributes if you want. So now this should work. And there's still an incomplete string now on line 15. And that's this NC references. Unfortunately, when I created this file, you could see that it's split in 2 lines, which is not good. So I'm going to remove that. And I'm going to try again. And at this point, it created a pressure.nc file. And this, I can do an NC dump of that. And you can see that now it has the depth array. As I said before, it has the time, the pressure here, that is time, long, lat, etc. In fact, actually, I wanted to change that to be the pressure. I wanted to have depth instead of time, for example. So I can look for pressure. Next. So here, instead of having lat time, lat lon, I can just modify this and have it to be equal to depth. Okay, and if that's the case, then I don't need the time anymore. So I'm just going to take it away. Yes, and then I'm going to go up here, and I'm going to remove also time, since I don't no longer need it. These things I'm going to also remove because, well, actually, we can just put created by us. You can put whatever variables you want here. So I'm going to save that, and I'm going to recreate it again. And I'm going to look at it with the ncdump command, and now you see that pressure is a function of depth, long, lat. And if you go further down, you find that these fields are left to 0. There's no value in them. Okay. So why is it useful to have a script like this? Well, in principle now, what I can do is I can make this a function. I can call this create underscore pressure nc, and I can have as argument the file name that I want to create, and maybe even the dimensions. For example, I can in principle pass as argument these dimensions, or if I want, I can pass the pressure field that I want to save in this file. Okay. And then here, what I can say, then I can go here, and instead of having this static name, I can just use the variables. Okay. And now the next thing that I want to do is, once I create the file, I actually want to store the pressure field inside the Netcdf file. And so I'm going to go at the end here. And I'm going to say then, I'm going to reopen this file, nc equals netcdf of file name, which is what we just created. And we are going to open this file for writing. And then we're going to say nc of pressure, which is the variable that I want to write, of all the values, so that's 3 dimensions, is going to be equal to our pressure field that I'm going to pass as an input argument, and then I'm going to close nc. Okay, so I'm going to save that. And now if I just attempt to run the script like this, it's going to say that it wants some input argument. And so now I can give some input arguments. I want to call pressure, the file called pressure.nc, for example. and I have to give a value for the pressure. In this case, I'm just going to give all zeros. Okay, actually let's put all tens, okay, just for practice. And then I can press return, and it's saying that this file was not open, and that's because it was not created for some reason. And that's exactly right, because I made a mistake here. When I wanted to open this file, it's actually, I have to put here the file name instead of pressure. So I do that, okay. And I'm going to try and execute this again. Okay, so now it seems that it worked. It should have created a file pressure.nc, ls minus rtla. So it did create a pressure file called nc, and it should have set the pressure field equal to 10. So we can verify that very quickly by just doing nc dump. We go here, and then when we get to the pressure field, now you see that it's all initialized to 10. So in principle now you can create or write at the same time a Netcdf file, but more importantly, if you open this function, you have a template to create a Netcdf file, and you can fully customize this to be a dynamic creation where you can pass the, for example, the dimensions of the parameters. So for example, you can improve this by saying, you know, for example, lon, lat, and depth. You can actually specify also the dimensions of your Netcdf file. And so here now, instead of having these static ones, you can add lon, lat, and depth. Okay, so now I've fully customized this script, and so now when I create my pressure, I also have to give the dimension size. So it's going to be, say, 180. Let's call it actually 20 by 20 by 5 depths. Okay, and then the pressure field here, which I'm going to put now to, say, value 30. Okay, these are the arguments of the routine. I can run this, and I got a mistake because I forgot to put a comma here. I can run this, and we can look again at the generated file, and we can do an nc dump, and we'll find that now the dimensions here are different. Okay, and if we go further down and we look at the pressure field, it's actually equal to 30, as we did. Okay, so this is a nice way of creating, you know, dynamic scripts. And in fact, you have some functions that are part of the ROM's RNC package here that will actually create empty Netcdf files with the dimensions of the grid that you're currently working on, and it will create the initial condition files, the forcing file, the climatological files, and boundary condition files. So we can try, for example, and so we load grd equals rnt grid load. Let's load, for example, the Northeast Pacific grid that we already have configured, and let's say that we are going to name this application equals NEPD. Okay. So then here we're going to assign some name of these files. Okay, which are going to be NEPD clima, so this will be the climatology, say a boundary condition file, initial condition file, and then we can just use these predefined functions of the RNC package to actually create all these files. So let's actually execute this. So first we assign the file names. So we go here, we just paste that. Okay, so we've loaded now the grid, and we did that. So the fork file, for example, has this name. And now we can just create, you know, for example, the initial condition file. And by passing this GRD array, which is the grid, it has all the information that it needs to create an empty file that has the right dimensions. And so we could do F12. And okay, file name, in this case, it's init name. Well, let's see how it's called. How did we call this initial condition name? We call this init file. Okay, so let me just change that. Init file. Okay, let's save it, and let's create this initial condition file. Okay, so it did create it, ls minus rtla, and you find now that you have this NEPD init. Now this is the initial condition file that has a dimension that are that you will use with the grid that you selected. So if I do an nc dump of that to just quickly look at the structure, you find that it has a typical structure, you know, of a Netcdf file with the dimensions of the grids of the model. And if you go further down, you'll find that it has the state variables like u bar, v bar, which are the state variables of the model. Now, of course, you can populate this file, by putting the values. And the nice thing is that if you look again, this has already the right dimensions of the grid that you're working, but if you load a different grid, for example, let's load the Coriolis grid. I think it's called Coriolis. Let's see if they exist. Okay, and now I can just recreate a new file here, and instead of calling it NEPD, I can call it Coriolis.nc. Let's call it init. Okay, I can do that. So now I have another Netcdf file that is now for the Coriolis application. And if I do more, you find that now the dimensions are different and so forth. Okay, the same is true. You can use the same command now to create, for example, the forcing file, the climatological file, the boundary condition file, and I can just execute these like this, and it's just going to create them. So, for example, created now for the NEPD grid. Okay, so this is all for creating and writing Netcdf files, and of course for writing Netcdf files so far I've showed you that the most simple way to do it is at the end of this Matlab script, where you open the Netcdf file with this W, which is to write, and then you take the pointer of the variable that you want, and then you just take the dimensions where you want to write. In this case, pressure has 3 dimensions, and I'm going to write the full 3-dimensional field here, and you assign the values whatever that is, and then you close the Netcdf file. If, for example, you only wanted to, in this case, write a record for depth number 1, then here you would just replace this with 1, and you would just write the first record, and so on. Okay, so this is all for this template.